till 6:10. So how was your exams?
Sir, easy.
Okay.
Good, sir.
So is this quiz one or qualifier exam?
Sir,
It was
quiz 1.
Okay. Okay. Okay, can we start?
Yes, sir.
Okay.
Yes, sir.
So this is week 5, and we will discuss content of week 5 if you have any doubts. And okay, let's see.
Okay, sir.
Okay. So in week 5, what we discussed? Hello.
So this is the first session for week 5.
Yes, sir.
Okay, so in video lecture, have you watched those video lecture or not?
Not yet, sir.
Okay,
No,
Not
sir.
yet, sir.
if anyone, then what's the content in week 5? If anyone know?
So log functions, exponential functions, inverse functions like that. That's it.
No. It's
Factorial and
yeah, it's counting principle.
counting addition and
Sir,
multiplication.
addition and multiplication
So
rules.
basically, it's permutation
and combination.
and what combination. Okay, basically counting principles. So we have two rules. If anyone recall that lecture, so we have two rules. One is what?
Addition rule of counting.
Yeah. One is addition rule, and another is
Multiplication rule.
Multiplication rule.
yeah. Okay. So what these rule are? What is this? Addition rule.
N1 plus N2.
Okay. So assume that you have some event. Okay. And you have, like, if you watch the lecture, there is one example that we have 4 shirt and 3 pants. So the question is, how many ways one can choose one shirt, or main thing is, or one pant. So what is the event here? Event is choosing the uh, pant or shirt. Okay. So how many ways some we can do this event? Anyone have any
Seven.
idea?
7 ways.
Okay. So see, now we have 5 shirt and 3 pant. Okay. So the event is choosing these stuff. So that guy can choose one pant, or that guy can choose one shirt. So this event can be happen in 2 ways. First is what? I can choose shirt. So I have 4 shirt. So I can choose any of 4. So total number of ways are 4. Now another event is what? I can choose one pen. So how many ways are I can choose these 3 pens? I can only choose one pen. 3. So total number. Okay. So assume that you have you are going there is 2 cities, city A and B. Okay.
But since it's an or condition, we can also choose a combinations now, right?
No,
No?
it's or
Okay.
only one. Only
Okay.
one. Only one.
Okay. Got it.
Yeah. Now, if I'm saying that okay, we have 2 cities, and I can go from city 1 to 2 by multiple ways. First, by flight. Okay. Okay. Now, second, by road. Second is also by flight. Third is by road. Okay. Then fourth is train, and fifth is also train. So how many ways I can go from A to B?
5.
Yeah. So what is the event? Event is going A to B. Now I can go. I can do this event A to B in 3 procedure. One procedure is what I can go by flight. Second is by road. Third is by train. In flight I have 2 options. In road I have 1 option, and in train I have 2 options. So how many options I have?
5.
5. Okay. So in addition, what we have one event, and I can do this event by multiple processor. And yeah, okay. Let's see. So what let me say later. So if an event can be happen by processor one by process 1, I can do this m ways, and by process 2 I can do this event by n ways. Okay. Then the total number of ways to do this event is what?
M into N.
No, m plus n. No, I have one event which can I which can be occur in 2 process. I can do this event by process 1 or by process 2 or okay. If I say there is one event which can happen in 2 processor. First is like A to B I go by road, and then B to C by flight. If this is the case, then I will use what? Multiplication U. But one and process 2, and in process 2 I have m ways, and in process 1 I have n ways. So how many ways I have?
M plus n.
M plus n. Okay. Now in multiplication rule, same condition. Assume that there is one. Okay. uh, this is one whole process. Okay, this is okay. Now there is two things I can do: event one and event two. Like I have three cities A, B, C. I can here I have option by flight, one flight, then another is one flight, then another is one road. Okay, sorry, one, two, three by road and by train. And from B to C, I have how many options? Say three options. All are road, 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 road. So I want to go from A to C. So this is my whole process, and I can do this process in two events. One is going 1 to 2, and then another is B to C. So this is event 1, event 1, and this is event 2. Okay. So how many ways I can go from A to C?
30 ways.
So how many? 1, 2, 3, 4. 4 into 3. It's 12.
Sorry,
See,
sir. I thought 1, 2, 3, 4. I summed
no, no,
all.
no, no. Okay, so this is the one flight, second, third is the sequence. Okay,
Oh,
no
it was
problem.
first and second. So I thought it is one ways or two ways.
No, no. Okay, no problem.
Oh, then it will
So
be 12 ways. Okay.
yeah. So if I choose this flight, okay, this way, say this is F1. If I choose F1 to go A to B, then how many ways I have left? I can choose one, road 2, and road 3. So for F1, I have road 1, road 2, road 3. Similarly, for F2, I have how many ways? Road 1, road 2, road 3. If I choose F2. If I chose R not, road, then I have same. Similarly, for train, for T1, I have R1, R2, RT. So how many ways I have? 12. So if I have, there is one big procedure which can occur in two event or two process, and this event happen in m ways and this event happen in n ways. Then how many ways this event can be occur?
MN.
Mn. But there is one condition. What's the condition? If anyone know?
Events occur simultaneously.
No, no, no. Condition is that these ways are independent of these ways. So let's see here. If I say that if I choose F1, then I have to be choose R2. Then there is condition on R2, F1 and R2. If I choose F1, then I have to be choose R2. There is no another way. If I say this condition, then these are not independent. Okay. Everyone got the point, this point?
Yes, sir.
Yeah. So this is the main point of multiplication rule, that these ways are independent of these ways. Okay. Assume that there is one more path by train. Okay. So if I say, if I go from A to B by train, then I have to be choose again train T2. Then this is the condition. So T1 and T2 are not independent then. Okay. So make sure that your events are, when you use multiplication rule, then your events are, these ways are must be independent. Okay, let's see one example. Let's say you want to go from A to B and by B to C. So first is F1, F2, T1. This is B1, which is bus, and here you have F3, T2. Okay, so now question is, how many ways uh, one can go from A to C if there is only one way to go from A to B to C is train. Okay, no flight. In this case, assume that no
4.
flight. So how many ways one can go from A to B?
4 way.
Okay,
4 ways.
so yeah, if I say, if person choose flight for A to B, then the person must choose flight for B to C. So how many ways are there?
5 ways.
2 ways.
No, see, person can choose F1.
Sir, can you explain once again?
5 or 6 ways, sir.
Let's see how many ways. I also don't know
8 ways.
answer. I just create the example. Okay. See, question is, a person wants to go from A to C, but there is two ways, two steps. Firstly, you have to go from A to B, then B to C. Okay. Now for A to B, we have these four options: two flight and one train and one bus. And for B to C, we have two options: one is flight and one is train. Now question is, if person choose flight for A to B, then he must choose flight for B to C. Okay. Okay. So if A to B is flight, then B to C must be flight. No other condition. So how many ways a person can go from A to C? This is the question.
So, but it's like from A to B, the lower side is bus,
Yeah,
or
bus B1. Bus.
and there is no bus from B to
6,
C.
sir.
Yeah, there is no bus from A B to C.
Okay.
Yeah.
Sir, 6
Conditional
ways.
is how many ways?
6 ways.
So
Okay,
total
let's
3
note.
ways.
How many ways?
3.
3 ways.
Yeah, because it's like from A to B, it's F1, then B to C, it's
Okay, we
F.
see. We will see how many
8
ways?
ways.
One way.
2
Okay.
ways.
We will-
2 ways,
One
sir.
way.
2 ways.
Okay. And any other ways?
8 ways, sir.
8 way. Okay. Okay. Let's see what's the answer. So if person choose F1, then he must be choose what? F3.
F3, yes, sir.
Okay. If person choose F2, then
Then
person must be choose F3.
yes,
If
sir.
person choose T1, then how many ways I have?
F3 and T2.
Yeah, F3 and T2. If person choose B1, how many ways I have?
Then also F2, F3 and
F3
T2.
and T2. See, the condition is, if person choose flight for A to B, then he must choose, there is no condition. He only go from B to C by flight. Okay. This is the condition.
Mhm.
Okay. Now, if person choose F1 for A to B, then he can only choose F3 for B to C. Is this clear?
So the question is,
If a
Yes,
person
sir.
Person
chooses,
wants to go from A to C.
if he chooses flight from A to B, then he has to choose only flight from B to C.
Yeah, yeah.
But if he chooses anything else, then he can choose anything in B to C.
Anything else? Yeah.
But in the question, we won't get like that. We'll get question that if a person chooses flight, then from A to B, they have to choose only flight from B to C.
But if you see in the book, question are like this. They don't specify that if person choose T1, then that guy can choose F3 and F2.
They don't
They
tell
give
us in the
just one
question.
condition.
Okay.
Yeah.
Then how will we know?
What?
I mean, when they give only one condition, we assume that we should take only flight F1, F2.
Yeah, you have to be assume.
Okay.
Otherwise, no sense in the question.
Okay, sir.
Yeah. So if now how many ways I have?
So
One, two.
for if for the case if it was said that the mode of commute would have been the same, then that this condition of flight to flight would have been extended to all the transportation, no?
Yeah, yeah, yeah. If question is asked about mode of transport is same, then question is different.
Yes, sir. Got it.
Yeah. We will see that question is also. Now, how many ways we have? Answer is 6.
6.
Okay.
Can you please answer the other question? Other person now mode of transport.
Yeah. We will discuss. Now question is if I choose from A to B is flight, then I have to be choose B to C flight. If I choose train, means transport is same. If I go from A to B by one transport, then same transport I have to be used for B to C. Okay, this is the question. If I choose train from B to C, then I have to be choose train for B to C. Okay, same for bus.
Okay.
Now this is the condition. So how many ways I can go from A to C? So means these events are not see. My whole process is going from A to C, and there are two processes. One is going from A to B, then B to C, and these events are not independent. There is one condition. That's why I'm discussing this question, so that we can't use multiplication rule simply. Okay. In multiplication rule, for multiplication use, the condition is these ways are independent. The ways by which event 1 is happening and event 2 is happening must be independent. That's why I'm discussing this example. Okay. So how many ways can you answer?
3 ways.
So,
Okay. Let's see.
Uh,
Answer is
3 ways,
3.
sir.
Okay. How many ways?
3 ways, sir.
Okay. Let's. So if I choose F1, then I have to be choose F3.
F3.
If I choose F2, then I have to be choose
F3.
F3. If I choose T1, I have to be choose T2. If I choose B1, then I can't choose anything. So I can't go by bus. So 3 ways answer. Okay. So
so
yeah,
can you please write question also for different mode?
for different mode. So question is for A to C, from A to C, A to B, and then C. A to B and so transpose must be same. Way of transport must be same.
Okay.
Okay.
Yes.
Yeah. Okay. Now what next we have to be discuss?
So in this type of question, like we are only able to calculate by using this particular cases. But
Uh,
is there a way to apply this multiplication and this addition principle here?
yeah, there is way, but you have to be careful for that. See,
Hmm.
if I use here in this example, no, in this example, where if I use flight, then I have to be use flight for B to C. Okay. In this example, I have to be separate my case. Like means you can't directly use multiplication use. You have to be separate the things and it's okay. That's so
Okay, means even if in that case we will first have to formulate some cases
yeah
that
yeah 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 yeah.
that
yeah.
okay.
Formulating casing is must. You have to be formulate case.
Okay, sir.
Yeah.
Yeah.
Okay.
Sir,
Yeah.
so in this question, the second action is dependent on the first action. That's
Yeah.
what you're saying.
Yeah.
Okay.
Yeah. And first action is also depend on second. If I choose flight, then I have to be choose flight.
So they're dependent on each other.
No, not dependent. If in this case, if I choose flight here, then I
Mhm.
can choose either flight, either train, or either bus. But if I choose flight here, then I must be choose flight here. Okay.
Okay.
Yeah.
Okay.
Why, sir?
Because this is the condition.
That, sir, then why you choose train for flight?
See, condition is that. See, condition is there.
But it's
A
from
to
A
B.
to C, right? So we cannot choose
See, I am
F3
going to
first, right?
going to
But
A to
from
B.
C to A, there may be different conditions
Yeah.
given.
See, if I go by flight from A to B, then I have to be choose flight. But there is no condition on other transport.
Okay.
I can choose flight for these transports also. If I go train from A to B, by train from A to B, then I can use also flight for B to C. Condition is
Okay.
all only for this.
Okay.
Okay. Yeah.
Sir, condition is that we have to choose the same transportation.
In that case, yeah, that case we already discussed now. See,
Here also same case is following.
yeah, for same transporter we have three cases. I can use F1, F3, F2, F3, and T1, T2.
But here there is another case T1 F3.
T1, F3, no. If I choose, see, transport is same means if I choose transport T1, train in first for A to B, then I have to be choose a train for B to C. I can't choose F3.
Yeah.
Yeah.
So we have only three
Yeah. So
for same
for same
transportation.
transport, we have only three. But for first condition that if I choose flight for A to B, then I have to be choose flight for B to C. For that, we have six ways.
Sir, can you like formulate the first conditions and write down the question?
Okay. See,
Not
A, B, and C. Now I have F1, F2, T1, T1, F3, and uh, T2. So if if A to B is flight, then B to C is also flight. Okay, this is the condition
okay.
for first one.
Okay.
For second one, uh, if A to B, I choose X. X, assume that this is the one transport. Maybe F1, F2, F, maybe F. See, this can be F, T, and B. Then B to C is what? X. Same transport, but indexing can be changed. See, assume here we have F1, then we can't have F1 here. We have F3. Okay. So this is the second condition. For question one, we have condition this. For 2 we have. In this question, our answer is 6. In this, we have 3. Okay.
Sir, one question, sir.
Yeah.
So, what if a person have one more option of directly going A to C with different modes?
Then that question is different. We have to be see if you want to say that if person have direct, that this is the separate case. You count this in separately. Assume that this is, then you count this 1 plus, then create this setup again, and this is, assume that we have condition. If I choose first f1 and then f1, then I have 6, then I have total 7 ways. Then that question is totally different, and you have to be separate all the cases.
Means whatever the number of modes of transport going from A to C, that will be added in the
Yeah.
final answer.
Yeah. So if you making case, in that case you have to be add all the answer of all the case. And assume that in this case I made some cases, like I use f flight for A to B, then I have how many ways? I have 2. And if I choose T, then I have how many ways? I have 2. And if I choose B, then how many ways? I have 2. So I have to be add these cases. In between cases, we have to be use addition, because I can use, here we have or option. This one or, so we have to be add. Answer is 6, like this.
How the question will be in multiple cases, sir?
There will be some condition. Let's see how. Okay. Question are like, just wait, I have to think about it.
So could you repeat the cases, please? My network signal was not good. I was not able to listen completely.
No, it's just previous one.
Okay,
That
okay.
first one we discuss.
Okay, sir. Got it.
Yeah.
Sir, I have a doubt.
Okay, ask.
Sir, in a particular question, how to know that that question solve in adding process or multiplying process? How to know that, sir?
That's why I see, for multiplication rule, what we have one process. Assume that one event, and I can do this event in 2 ways, 2 process. Assume that P1 by process 1, P2 process 2. In process 1, I have m ways, and in process 2, I have n ways. So how many total ways I have?
2 ways, sir.
M plus n ways.
Yes, sir.
Yeah. As in multiplication case, assume that this is the event, and this event happening 2 parts. First, like this. First, I have to do event 1, then event 2, and this event can be happen in m ways, and this one can be happen in n ways. Then how many ways this event can be happen?
M into N.
M into, assume that, see, I choose 1 ways from here, then I have n ways for this one, this particular. Assume that we have, I m1 is 1 ways, m2 is second ways, dot dot dot, m is mth ways. Similarly, I have n1 is 1 way, n2 is 1 way, dot dot dot, and n is nth ways. Okay, I choose this way.
Yes.
Then how I have n ways here for this one, so I can write m1 n1, m2 n2, like this. Same for this one, same for this. So For each m case, I have n this sum. Okay, so how many ways I have? M into n. Okay,
Yes, sir.
yeah. Okay,
Sir, this is
now
condition.
not this is not condition. For condition,
Sir,
you have to think about separate ways. You can't use this formula for condition one.
okay, sir.
If there is
Sir,
condition,
how to know the multiplicity condition and adding condition?
multiple condition, and in question, if see if in question, if question ask about some event and this event can be happen in two ways, then you have to be use
Yes, sir.
addition rule, and these two ways are independent, these two procedures are independent. Same here, these two procedures are independent, then you have to be use multiplication rule. If question says that the event is happening to process, in process 1 we have m ways and in process 2 we have n ways, then how many ways we have? And these ways are independent to each other, then I have m into n ways. But if these ways are not independent, then I can't use this formula. That's why I'm discussing
Sir,
this example.
So in m, the
question.
first case m plus n, it is independent or not, sir?
Okay.
It is dependent, right? First case.
No, not dependent. Why?
The addition rule.
In addition rule, the question is in you. If you see lecture, the question is 4 shirt and 3 t-shirt, and you have to be choose one. Either you can choose one shirt or one pant. Okay. So what is the event? Choosing pant or shirt.
Yes.
Or how many ways you can? How many procedure are there? One
7.
is you can choose shirt, and second is you choose pant.
7, sir.
This one is P1. This one is P2. Okay, so how many ways we have here? For P1
7.
we have 4 ways. For P2 we have how many ways?
3.
3.
3 ways. So how many ways we have?
7.
7.
So there is no dependency now. If I say that the person who choose shirt must choose pen, then there is the condition.
In the lecture, it was given like if a person chooses a shirt,
Yeah.
then he cannot choose a pant. So
Yeah.
that is the
That's
addition rule.
That's
Anyone, right?
that's I think I see. When I ask the question, then I say that person can choose either shirt or pant.
Sir, you
Then
said one more case after this. You said if a person chooses
what? If
a
person
shirt,
choose,
then they have to choose a pant.
yeah, that is the another condition. If
How
I'm
will we
stating
decide?
my question like this, if I'm
Okay.
stating my question like this, then I have to be then there is the dependency.
Then how will we find the answer for that?
For that question,
Yes, sir.
for that question, our experiment event is also different. In this type of event, I can't use that. See, my event is what? I have to be choose either shirt or pant. I can't choose both.
Yes, sir. That we already discussed. But you told one more question that when we
In that,
choose.
yeah, in that question, our event is also different. I have to be also state the event.
Can you tell me the answer? Can you tell how to find the answer, sir?
So for that, I have to see. If I state my question like this, I have 4 pant of the 4 shirt of different color. Okay, C1, C2, C3, C4. Okay, and I have pant of also different color P1, P2, P3. assume that, okay, sorry, I have to be used red. Okay, red, green, and black. These are the 4 pants and 4 shirt, and I have pant red, green, okay, and green. If I state now my experiment is different, not like this. Now my experiment is choose pant and shirt such that if I choose red shirt, then I have to be choose red shirt. Okay. Then there is the dependency case, and I have to be use multiplication rule for that case,
Can
not
you
fully
prove it?
multiplication.
Can you please show that, sir?
What?
Can you please show how to get the answer for that condition?
See, so if I choose the R1, R2, R3, R4, B, okay, B1, G1, B1, R3, G2, B3. So I can choose R1. If I choose R1, then I have to be choose R3. For R2, I have to be choose R3. If I choose G1, then I choose any of the 3. If I choose B1, then I can choose any of the 3. So how many ways I have? 2 plus 3 plus 3. So answer is 8.
But in the question, they would have given only for red shirt, red pant. They will not tell about green and black.
But I can choose that. Question only give condition for red pants,
Okay.
red shirt. Okay.
Sir, if it was like
But
color
I can
matching,
choose
then
also green one. What?
Sir, can you explain this again?
Okay. Assume that now in class what ma'am discussed, we have 4 shirt as one red color, second is also red color, third is assume that black color, and fourth is white color. Okay, and we have these are the shirt, and in pants we have red, okay, black, so B2, and we have white, which is also 2, and one any other color, okay, blue, okay, black one, okay, red. Okay, now if my question is choose one pant, or you can okay, you can choose either one shirt or one pant, not both. Okay, so how many ways you can choose?
7 ways, sir.
7 ways. You have to use addition rule.
Yes,
4
sir.
here and 3 here.
3 here.
So now if I choose, if I say now question is different. Now question is choose pant or shirt. You have to choose combination of pant or shirt such that if you choose red shirt, then you have to be choose red pant. Okay.
Yes,
Everyone
sir.
got the question?
Yes, sir.
So and no condition on other things like blue, black, and white. So how
6
many ways
options,
I
sir.
can?
6
What?
ways.
10, sir.
6 ways.
10 ways, sir.
Okay, let's see how many ways we have. So for if I choose a red one.
8 ways. Sorry.
Okay, if I choose a red one, then I can choose only these two from here and only one from here. So how many ways I have? Two. Okay. If I choose this black one, then how many ways I have?
3 days.
Three ways.
3 ways.
If I choose
8.
black,
Yeah.
black shirt, black, three. And if I choose white shirt, then how many ways I have?
3
3.
ways.
So how many ways I have?
8 ways.
8.
8 ways.
8.
Yeah. So in dependency and that condition, your question is also changed. So see, in this,
Okay, if the question is telling identical shirts and all, then how will we get it?
so, okay, identical. This means your pant and shirt color is same.
No, no. We have R1, R2 as separate shirts, but if
Yeah.
both are, can we interchange like that? Will it come?
Both
Not
are
like
interchange. So how?
like we have like questions, like identical.
Yeah, those questions are different.
Okay.
Yeah, here you can't use this. Yeah.
So
Okay, let's
for
see.
red, why we choose 2 and for black for 3
Because we have
option?
conditioned that if I choose red shirt, I have to be choose red pant. This is the condition for red shirt. Okay.
Okay, sir.
Yeah. So if you choose R1, you have to be choose R3. No other condition are there. So how many ways you can pick your combination? One is R1, R3. Second is R2, R3. Third is what? B1. For B1, you can choose B2. This one. Okay. And for B1, you can also choose W2. This one. And for B1, you can also choose R3. Okay. This one. These are the pant. So, and for W1, you can also choose these three also. What? B1, B2, W2, and R3. So how many ways do you have? 2 plus 3 plus 3, 8. Okay.
Okay.
So for the case, like for the first question that you just wrote, if it was, it would be like you can choose one shirt or one pant.
Yeah.
So does that case also included that I choose both of them and individual also?
What?
Like if the question would have been that you can choose one shirt or one pant.
Yeah.
In that case, do we also have to include a single case where we are choosing one shirt and one pant collectively, and rest of the cases we are only choosing one shirt or one pant?
I didn't get your question. So you
Okay.
want to say that if I choose red one, then I have to be choose red one.
No, no, no. If the question would have been you can choose one shirt or one pant, then how much cases are possibilities
Only
are there?
one. See, if question is one shirt and one pant, then you have to be choose means what?
It's the
You have to
multiplication.
be choose one set or one pant.
Yeah.
If question says one shirt or one pant, then you can choose either one shirt, either one pant, or both.
Yeah, yeah. That I wanted to confirm.
I know, sir. I didn't understand. One shirt and one pant means what is the answer? One shirt or one pant means what is the answer?
See, if question is one shirt and one pant, then this means you have to choose one shirt and one pant. Okay. If question is one shirt or one pant, then you can choose either one shirt, either one pant, or both. You can choose both shirt and pant. And if
Sir,
question is
any
either one shirt or one pant, then you can choose only one shirt or one pant. You can't choose both.
Yes,
How, sir? Right?
yes,
Oh,
yes.
when either is given, then
Yeah.
oh.
Yeah, it's about either.
Yeah.
sir, any random shot we can take, or should they be the same?
Same.
As per
Same shot
question.
and same pant?
Yeah, same set. You can apply this question in same set. But yeah, your condition, if you want to include your condition, then for this your statement is different, question is statement is different. Here your question is, uh, assume that you want to buy one pant or shirt. No, one pant and one shirt. You want to buy one pant and one shirt, and there are pant, four shirt and three pant. So how many ways you can buy?
12 ways.
12, first one was 12.
Okay, 12. And if your question statement is what? Uh, you want one shirt or one pant, or you can buy both. Okay. In that case, how many ways you have?
19.
19 ways.
Yeah. For
How, sir?
see, if that guy choose
12
both,
plus 7.
then we have 12 case. We will already discuss. We already discussed this case. One shirt and one pant case we already discussed. And then other thing are what? Either one shirt or either one pant. So
7.
how many? Plus 7. How many?
Okay, 19.
Yeah. If question is this one, then you have only 7 ways. Okay. So in all the cases, our question statement is also changed. This means our event is also changed. In that case, I have event that I have to choose both. In that case, my event is I can choose one shirt, or I can choose one pant, or both. In that case, I can only choose either one shirt or either one pant. Okay. So this will be used in your probability theory for describing event and these things. Okay.
So in case of either, it was written that both one S or one P, one shirt or one pant.
Yeah. In either.
So in place of either, it was written that both, then
Both. Okay. Yeah. Okay. Both x1 or x2. One shirt or this not make sense. See,
That
if I wrote
becomes
both
and condition.
one
Both
shirt, or this is not, this statement is not valid.
Yeah, if we use both
If I can,
one
if
shirt
I use
and one
both
pant,
one shirt or and one pant,
and
then this
then it
statement is true.
become the first case.
Yeah. But in this case, if I say both one shirt or one pant, it don't make sense. Okay.
so
Sir, one shirt and one pant means any random shirt and random pant, or like should they be same
No, any
pair?
random, no condition. If there is
Okay, same
condition, you
like
have to be
intersection, right?
what?
It is similar to intersection.
Uh,
One and means like
Not that
intersection, and
intersection.
or means union.
Yeah. In second case, you can use see, in one shirt or one pant, you can use your union formula. But in one
Okay.
shirt and one pant, you can't use your intersection formula.
Yeah, yeah.
Yeah.
Okay.
Because there are ways, not you are choosing. See, in this case, assume that
Here
one
it's a
shirt means,
relation. We can take cardinality.
see, these or these operation used in what? In sets.
Yeah.
Okay. For first case, I have set like
Yeah, that is
my
union.
red one, red 2, B1, and W1. This one is my one set. Or uh, what? R3, W2 and W B2 and W2. I have said I can use, but for this case, I have like this R1, R2. I have no two set. There is only one set R1 and R. Okay, R1 and R3, R1 and W2. So this is not like an intersection. Okay. So don't use union and intersection here. Just use multiplication and addition rule.
Sir,
Sir,
and means
I
like
have a
it is similar to cardinality of sets. We are taking
Yeah, you can say.
yeah,
It's,
we are taking multiplication.
yeah. In there we also use this type in. I think in bijection and that thing we can in
Yeah, it is
permutation we also use bijection on these things. Okay.
and means it is kind of cardinality of or
Yeah.
relation.
Yeah.
Sure.
sir, I have a doubt
Makes
in a
sense.
question.
What?
I have a doubt in a question, and I sent in a chat box.
Okay. What is the question? In how many ways can a number can be chosen from 1 to 20? 20 such that multiple of such that it is multiple of 2 or 3. Okay. So your question is you have just number from 1 to
20.
20 and then how many ways you can choose? So what's the question? Okay. Such that it is multiple of how many ways number can be chosen from 1 to 20 such that it is multiple of 2. So 1 to 20, how many ways? How many numbers are multiple of 2
10,
in
sir.
1 to 20? 10.
Second number, so that's 20 by 10.
Okay. What?
Also 20 by 2, sorry. 20 by 2.
Yeah. In the second question, he asked about multiple of 2 and or 3. Oh, sorry, or 3. So there is one event is that you see total event is what? I want to find that all those number which are multiple of 2 or 3. So P1 is multiple of 2, P2 is multiple of 3. So how many numbers are multiple of 2? 10. And how many number are multiple of 3?
6.
6. Then I have to use what?
10 plus 6.
Addition rule?
Yes, sir.
Yeah, so 16. Now another question is what? Multiple of 2 and 3. Then how many ways?
No,
How many numbers
sir,
are
it's
multiple of 2
only
and 3?
2 or 3.
Yeah.
It may be 3, sir.
No, only 2 or 3 is there.
They okay
Now
numbers.
this is one another example. Another question.
Yes, in 2 or 3, sir. In that case,
3 ways, sir.
they've I mean number 6, number 12, and number 18 is both multiple of 2 or 3. So we should reduce that count.
Okay. So, sorry. Yeah, how many
Common
numbers are?
numbers.
Yeah.
Three numbers.
Here
6,
you have
12,
to be
18.
use set thing, your set formulas. Okay, sorry. 13. Yeah.
How to is sir 13?
See, number of multiple of 2 are what? 2,
10,
4, 6, 8, 10, 12, 14. Oh, 12 already have.
16,
16, 18, and 20. And how many numbers are multiple of or? How many numbers are multiple of 3?
3, 6, 9, 12,
3, 6, 9, 12, 15,
15,
18.
18.
But why this number and this number already counted. See,
But if we consider just a second.
yeah. So what is the union of these set?
2, 4, 9.
Yeah, 2, 4, 6, and 8, 9, 10, 12, 14, 15,
14,
16, 18, and 20. So
20.
how many numbers are in this set, union of this set?
13.
13. Okay, so we can't use multiplication in here. Okay.
Sir, 13 would be when we are asked that the number should be multiple of 2 or 3, not
Yeah.
both.
Yeah, not
Not
both.
both.
Yeah.
Sir, why not both? Because we have taken
No.
18 once.
No. Both also fine, no?
Oh, sorry.
Yes,
Yes,
Yeah.
like,
we have just removed the duplicate number.
Yeah, we just do over counting.
okay.
Yeah.
But the
In
question
this
doesn't
case,
state this.
what?
Sir, but if we if we look on this, like, we have total condition like 10 plus 6 na.
Yeah, but
Like if
we can't use multiplication because they are not independent. See, multiple of 2 are not independent than multiple of 3. 6 is multiple of 2 and also multiple of 3. Okay.
Sir, if we are told to find ways to find the multiple of 2 or 3, then for finding multiple of 2 there are 10 ways, and for finding multiple of 3 there are 6 ways. So
Yeah.
total, if we take ways, then it will be like 16 ways. But if we talk about number, then only
No,
it will
but
be like 13 number.
question is how many ways you can choose number from 1 to 20. Those are multiple of 2 or 3. Okay.
Yes, sir.
So if I choose 6, this means it is also multiple of 2. It is also multiple of 3.
Yes,
But
sir.
I can't use this 2 time in my set.
Okay.
Yeah. So that's why I remove one condition. 1, 6 I remove. See.
Yes, sir.
Yeah. So if my question is multiple of 2 and 3. So how many ways I have?
3.
Yeah,
3.
3. If my question is either multiple of 2 or multiple of 3.
Sir, then only 13 will come, sir. Then
Yeah. Then only 13 will come. Okay. So everyone got the answer? How 13?
No, sir, in that case, no, it should be not less than 13. That is like it should be 10 now. When we are saying either 2 or either 3,
Yes, for,
that
Yeah.
for,
means not include
yeah,
Either
for
this
either
means
or case we got 10.
okay, just a second. Either 2 or 3, but not 2. So I have to be remove 6. See, I have to
12
remove
and
6,
18 also.
12, and 18. Okay, so how many
Yes.
ways? 1, 2, 3,
So
4, 5,
so
6,
13
7,
minus 3.
8, 9, 10. Yeah, 10 ways. I can't use both. So you have to be aware about this when to remove one. Okay.
So we uh, can't use both, but we have to use one now. So we
Yeah,
will take it to for one time, either in 2 or either in 3.
but see, if I say that either by 2 or by 3, this means it's either multiply by 2 or multiply by 3, but not multiply by 2 or 3. Okay. Yeah. Just a second.
Yeah, sir. Okay.
Okay. Yeah, either multiply by 2 or. So if I use this, number is multiplied by either, no, not 2 or not 3. What's the answer?
So in starting, either is also there.
7. 20 minus 13, 7, sir.
Let's see.
Yes, sir. 7.
This is 1, but if my divided by 2 intersection 3 complement, I can write it like this. Okay. Divided by 2, if I expand this, this is what? Not 2 or not 3, right? Like this. 2 complement union 3 complement. De Morgan law. Right?
Yes, so after complement union becomes intersection and Indian intersection becomes union. That's fine.
Yeah. Then how many ways I have? Just a second. Total number of ways. Two, one, okay. Just do by simply. How many ways? Not divided by 2 or not divided by 3.
Sir, in either case, even if we go for complement, now we will still need to denote this elements that are not divisible by 2 and 3.
Yeah.
Then
just do by this.
in that case, it would be not 2 and not 3 because you have
You have to be see how many element in this set.
intersection.
In this intersection divided by 2 and 3. There are 3. Which are the element? 6, 12 and 18. And complement is this set is what? All the other set.
17. 17 numbers are there.
Yeah.
But how, sir?
But sir, you have
Uh,
used or there, not and. Then how can you use intersection? Because intersection means you take
Just a
both both elements in answer.
sir, it is.
Just a second. Divisible by 2, not divisible by 2. This means what? 1, 3, 5, 6, 7, 8, 11, 13, 15, and then 17 and 19. Not divisible. 3, this means 1, 2, 3, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19, 20. Okay. Then not divided by 2 or not divided by 4. So how many ways we have?
7 ways.
So 1 is there, 3 is there, 5 is there. So how many set are in this set? 1 is there, 2 is there, and 3 is there. Okay, 3 is not. Okay, 3 is there. Why 3 is there?
It is not a multiple of 2.
Yeah.
No, sir.
Then we have 4 is there. Why 4 is there?
Not multiple of 3.
Yeah. Then we have 5. Then we have what? 7, 8, and then we have 9.
No, 9 will not. Oh, 9.
Not multiple of 2, na?
Okay.
Just a second. Just a second.
Sir, we are given the question not 2 or not 3, right?
So 10 is there. Okay. 11 is there. 12 is there.
No.
Okay.
No, sir.
13,
Yes, sir.
14, 15, 16, 17, 18 is not there. 19 and 20. So how many element are there? See, 17.
Okay, sir.
Yeah. So why you got 7 answer?
Sir, is not this the same that the total number of elements minus
Yeah, that's why I'm using this one, na. That's why I'm using this De Morgan law and that thing. Okay. Now what we have? Now we have factorial representation. So what's the factorial representation? So see, as the chapter name is permutation and combination. Okay. So what is the mean by permutation and what is the mean by combination?
One doubt, sir.
Yeah.
In the examples you shown there, so we are only counting the number of outcomes, like from 1 to 20.
Yeah.
Because if you go upon ways or like commonality, then the answers can be different. But is it just we can
See,
answer just on
we
the
can't
basis of
use
how?
addition and multiplication because the event are not independent.
Yes, sir.
Yeah, that's why I didn't use that multiplication rule. And that's why multiplication rule, addition rule is also failed.
Yes, sir.
Yeah.
Sir, how
Because
to
What?
find out from the question?
Find in those questions.
Yes, sir.
You have to be see are my outcome are that the way in ways in procedure my outcomes are ways are independent or not. You see in this case.
Sir, if they are not independent, then both addition rule and multiplication rule will not applicable, right?
Yeah, it depend on the question. See, everything is depend on the your question statement. According to that, your condition, your ways are independent or not. It's all depend on your question statement. For one statement, that event that procedure may be independent, and for another statement, that procedure may be dependent. Okay, so it only depend on your question statement. Okay. So, yeah. What is the permutation? Hello.
N factorial by n minus r factorial.
No, in general, in real life. Why you use permutation? And why we use this combination? As name suggests, this is the combination. So this is some kind of combine and combine the
Sir,
things.
I think combination is uses for counting and permutation is uses for selecting.
Okay, both are using for counting, the selecting. See, if
So if we want,
Order.
yeah,
Arrangement of events.
When we want to count with order, we use permutations.
yeah,
And then when we don't consider the order, we use
yeah,
combinations.
yeah. So as the name suggests, the combination. What is the combination? Assume that there is a some set. You choose some combination. This means if you choose this combination, these are then there is no ordering. It doesn't depend. You choose first this and then this, or you choose first this and then this. Okay, but in case of permutation, this matter. Okay, that you choose first person, then for second person, it matter. Okay, now what's the formula for permutation?
N
Assume that
factorial by n minus r factorial.
no, in some simple word. That's assume that you have 10 balls. Okay, and with numbering is there. Okay, 1 to 20, and now you want to uh, choose uh, uh, 4 balls. So how many ways you can choose?
That is 20 into 19 into 18 into 17.
Yeah, 20 into 19 into 18 into 17, and this can be also written in the form of what the formula you say.
20 factorial by 16 factorial.
20 factorial by 20 minus 4 factorial by 4 factorial, which is the formula of what? No, sorry. Yeah, but which is the formula of what? 20p4, right?
Yes.
Yeah. Now I can also derive formula of, if I say ball are not numbered. Just check it. Not number. Yeah. Yeah. Ball are numbered, but ordering is not matter. That here is the ball 1 and 2 and 2 or 1 the same. Okay, then in that case assume that firstly you permute your balls. How many ways? 19 into 18 into 17. Then you did some overcounting. Why? Because you assume that this one b1 b2 b3 b4 and b2 b1 b3 b4, like this. You assume these are all are different, but these all are same in this new case, that numbering is ordering is not matter. So for each permutation, you how many overcounting you did? 4 factorial, right? So I have to be divided by 4 factorial. So which is what? 20 factorial divided by 20 minus 4 factorial into 4 factorial. This is the formula of what?
20C4.
20C4. Okay.
So, could you shed more light on this division by 4 factorial? Why
Okay.
is it when why is division itself for avoiding? Why not subtraction or something else?
See, let's. So you choose one permutation, which is what? B1, B2, B3, B4. And in this, when you count this 19 into 18 into 17, how many extra counting you did? See, B2, B1, B3, B4. Same like these 4 factorial term, I count it is like 1. Okay. Now, how many combination I have totally? So if I write this into X, this is what my 20 into 90 into 18 into 17. This X is my all those combination.
Yeah, got it. Now means this 44 factorial times x, that signifies that 4 factorial signifies how we are reshuffling this x selected things, and that should be equal to this thing. Yeah, got
Yeah,
it.
each so in X, if assume that I have one B1, B2, B3, B4 in X. Okay, then 4 factorial times this one, I have permutation of this B1 or B1, B2, B1, B2, B3, B4 in permutation. Okay, so if I write this like this is the my one set, no ordering is matter. Then corresponding to this, I have 4 factorial item of this B1, B2, B3, B4. Similarly, I have another another combination. Assume that B2, B3, B4, B5. For this, I have 4 factorial permutation are also in my that in these permutations. So how many combination? If I have X combination, then for each combination I have 4 factorial permutation, which gives me total permutation. Okay, that's why I have to divide by 4 factorial.
Yeah,
Okay.
got it,
Yeah.
sir.
Yeah. So now anyone know what is the mean by permutation and combination? Okay. Now if you have any question on permutation and combination, you can ask, or we can solve permutation combination question.
So, can you
Yeah.
please explain combination again?
See, in combination,
Sir,
yeah,
sorry, when will be discussing like practice assignment and all?
after this you can ask
Week
from
5.
practicing. Yeah,
Okay.
week 5. Yeah.
Okay.
So now you have mm, you have 20 balls which are numbered. Okay. Now you want to arrange these balls in a cell which have 4 slots. Okay. In this case, you what you use? Your ordering is matter. Ball one is here or here. This one is matter. Okay. So what you use?
Permutation.
Permutation.
Yeah. So how many ways I have? 20 in 20 P 4. 4 are my slots, and total number of balls are 20. From 20, I have to be arrange 4 balls. Now, if my question is like, I want to collect these balls in a group of 4, means you put your hand in that what basket and choose 4 balls. Okay. So what is the possible number you can get? If I say this is the my question statement that you took 4 balls from basket. So what is the
Combination.
4? Yeah, you have to be use combination, that
But
A1, A2, A3, A4. No matter, you directly choose 4 balls. So
if
there is
they're
no,
telling one by one, you are choosing them.
if you choose one by one, then if yeah, if I choose here, I choose one by one. Okay, then one can say that I got first B1, then I got B3, and someone is say I get B3 first and then B1. These are different. Okay, so that if I use one case, I can use here. But if I say directly that I choose 4 balls directly, no matter what's the combination, I see balls and I got A1, A2, A3, A4. Okay, so no ordering is there.
Sir, in some question, captain, vice captain, and all, to choose a captain and a vice captain of a team,
Yeah.
then should we use permutation or combination, sir?
So okay. So in case of captain and vice captain.
Vice captain of a team.
Okay. So you choose. Assume that you have P1, P2, P3, P4, and P10. These are the pair. Okay. Now you want to choose captain and vice captain. Okay. Now you choose P1 as a captain and P2 as a vice captain. And someone choose P2 as a captain, P1 as a vice captain. So these two are different things. This means ordering is matter. So you have to be use what? Combination.
No, should we use combination or permutation,
No,
sir?
permutation, sorry. Okay. We have to use permutation here. Because ordering is matter.
Okay, they're saying we have an election and then we are choosing 2 people for one captain and another vice captain. Then should we use permutation or combination, sir?
What's the question?
Like if there's an election,
Okay.
election to choose a captain or vice captain of a team,
Okay.
and 2 people are chosen.
Okay.
Then should we use permutation or combination?
You have to use permutation. Or if the person directly choose yeah, it's use permutation. See, if I vote for P1 for captain and P2 for vice captain, or I can use P2 as a captain and P1 as a vice captain. So these two are different. Okay.
Okay, sir.
So I have to be use permutation.
We have to use permutation. Sir, in case of an example where some teams are some teams are competing by submitting projects, and
Okay.
4 teams are getting selected.
Okay.
So in that case, should we use permutation or combination?
4 teams. Okay. 4 teams are submitting
No,
project.
some 10 teams. Let n teams submit some projects, and
Okay.
4 teams are shortlisted or getting selected for the next round.
Okay. Then you have to choose combination. Because there is no position. You are the first, you are the second. They directly choose 4. So it doesn't matter that P1, P2, P3, P4 are first, or P4, P2, P3, P1 are first. 4 selected teams. Okay.
Okay.
So there is no ordering. So you have to be choose combination. Okay. So
So,
everyone got this idea of permutation and combination. When we have to be use permutation and when we have to be choose combination.
So can you please repeat once again?
Idea of permutation combination of this example or this example.
The idea of permutation and combination.
Okay. See, like in this captain and vice captain case. No. Okay. In first, I have question that we have 10 player in the team, and we have to be choose captain and vice captain. Okay. Then how many ways we can choose captain and vice captain? So see, I can choose P1 as a captain, P2 as a vice captain, and P2 as a captain, P1 as a vice captain. So these two are different ways. Okay, two different ways. So these count as two different cases. So I can choose captain in 10 ways. That P1 is captain, P2 in captain, P3 is captain. So here I use multiplication use. See how can we use how we can use multiplication here. So first event is what? First event is what? Choosing captain. Okay. So event one is captain choosing, which is happening 10 ways. Okay. Now I already select one person for captain. Now how many person I have? Player I have
9.
9. So E2 is choosing E2. E2. How many ways I can choose E2? E2 is for vice captain. 9. So total number of ways what?
90.
90. Okay.
Yes, sir.
So this is the case of permutation. Now assume that we have second example that n teams are there. They are submitting their projects. Okay. And at final 4 teams are selected. 4 teams are selected from n. Then how many ways this team can be selected? 4 team can be selected. Okay. This is the question. So assume that there are T1, T2, T3, Tn teams are there. Now someone choose T1, T2, T3, T4 for final round. Okay. For final round, we choose 4 team. And if someone says that T4, T3, T2, and T1 are selected for final round, are they same? Assume that there
Yes,
is
sir.
no first, second, third position, only
Yes,
selecting.
sir.
Yes,
Are they
yes.
same? Yes, they are same.
Yes, sir.
Okay. So they are same. So what we have to use here? No
Combination.
ordering is there.
Combi
Combination. So what's the formula of combination? NC4. Okay. Now if I say from these 4 teams in next round, uh, how many ways we can choose uh, first, second, third position? Assume that T1 and T2, T3, T4 are selected for final round. Assume this is the condition I give. So how many ways we can select our first 3 winners? First position,
24.
second winner, third position. So here ordering is
24
matter.
times.
24.
So see, this is the first position I can use 4.
4.
Assume that I pick one person. I can choose four ways. Then one team is already declared as first position. Then how many
Yes,
teams are
sir.
there?
3.
3. Then two teams are
2.
already gone. How many team are there? 3.
2.
2. Sorry. So what's the answer?
24.
24.
So here I use what? Permutation. If you 4C3, 4P3, sorry. These are the same. What is the formula of 4P3? 4 factorial divided by 3 factorial. Oh, sorry. 4 minus 3 factorial.
4 minus 3.
So what's the 4 factorial divided by 1 factorial, which is 4 factorial. So what's the answer of which is the 24? Okay.
Okay, sir.
Now clear?
Sir, if we were asked to like eliminate 2 members from there, then what could be the answer?
What?
Like eliminate 2 members from like eliminate 2 teams from the 4 teams,
Okay.
not on the basis of
next
order.
round. For next round.
Yes, sir.
Then again you have to be use. Oh, again you have to be use combination. See, if where is it? Okay. So 4 teams are assume that T1, T2, T3 and T4 are in the my second round.
Yes, sir.
Okay. Then in fourth round, how many way in third round, how many ways I can select 2 teams? So then use 4C3, 4C2.
Yes, sir.
Yeah. Okay. So here you can see that we use multiplication rule. See, for first event can be happening in 4 ways, second event happening in 3 ways, and third event happening in 2 ways, and independent of each other. Okay.
Yes, sir.
Yeah. Okay. Now you have doubts in what?
So,
Yeah.
so can you please explain formula of combination?
For formula of combination. Okay. From permutation or directly? See, for NCR, this means what?
Directly, sir.
I have n object and I want to choose 4 object from n object, and no ordering is matter. This means I want to collect R object from R distinct. I have n distinct object. All are different. Okay. And I want to choose R distinct from this object from n. So what's the formula? N factorial I can, and then n minus R factorial into R factorial. Okay.
So for the like the case that you saw that in 4 into 3 that we did multiplication,
Yeah.
you said that this event should be independent.
Yeah.
If they were dependent, then we have to make sub cases and then
Yeah.
add.
Yeah. In that case, you have to be add.
Could you please do one question like that, sir?
In that thing. Okay. Okay. Now, suppose that you are tossing a coin and dice. Okay. Then, so what's the outcome we have? Head, tail, and here 1, 2, 3, 4, 5, 6. So, how many combination I can get? Firstly, in first step, firstly I choose coin and toss the coin. After that I first, and after coin I toss die. So how many outcome are
Well,
there? How many outcome?
2 into 6,
well,
that's
Okay. So how many? 2 into 6. So these are one case. Here we use multiplication. Now I can also solve this by case. Assume that in first case I got head. Okay. Then how many ways I have? 6.
6.
Head 1, head 2, head 3, like this. And then assume that in second toss I get, in first coin toss I get tail. Then how many?
6.
6. So what is the answer? 12. So both are same. So here I use what? I make cases and then I add. This is for head, this is for tail. Okay.
so sir
You can also extend this idea.
in a sense, what multiplication principle is, like combination of similar cases,
Combination of,
like similar cases for like you just did now, like if I have had, then also I have like 6 cases, then
yeah,
I had tails, then also I have 6 cases for the
yeah,
dice.
yeah,
That essentially is means this addition thing is same performed by the multiplication principle. So if I say that if I have this as 2 cases,
yeah,
so collectively this multiplication principle 2 into 6 is taking care of both these possible cases.
yeah. So see, if I choose, so here is no independence. If I choose head, then in second one I can get 1, 2, 3, 4, 5, 6. Okay. If I got tail, then I also got 1, 2, 3, 4, 5, 6, 7. So for both I have 6, 6, which is 12. Okay. And you can also now assume that now my next case is what? If I got, okay, now I toss a coin, head and tail. Then if I got head, then I toss die. Then I have 1, 2, 3, and 6. Dot, dot. If I got tail, then I toss what? Head, coin again. Okay. So here I can use what? Multiplication rule with cases. Cases what? Firstly, I got head, so which is I can got only in one possible way, into 6 possible ways are here. Okay. I got tail, which is also can be obtained in one way, into 2 possible ways are here, which is 2. If I add this, what I get? 8, which is the total number of combination which I get from my processor.
I didn't
So
get it.
see,
So this is ordered. This is still ordered.
yeah,
So
yeah.
the
See,
permutation.
just again, how many combination I can get? How many ways output I get from this experiment?
That's 8 total, 8
Yeah,
cases.
or which can I got by what? Different 2 cases.
Yes, sir.
So I
Sir, I
use
didn't
case.
understand, sir.
Okay. So question is, if I toss a coin, if I get head, then I again toss die, not coin. Okay. And if I got tail in the first toss, then I toss what? Coin. This is the condition. Okay. If head, then toss dice, and if tail, then toss what? Coin. So how many outcome I get by this experiment? First is head 1, head 2, head 3, head 4, head 5, head 6. Okay. Now tail head and tail tail. These are the all possible outcomes.
Okay.
Now I can also find these by my cases. See, if I got head, then I have 6. If I got tail, then I have 2. Add these two. What's the answer? 8. So in the case, we have to use addition. This is case 1 and this is case 2. Okay. There are also some difficult problem, I think. Let me check if I have. Okay. Okay, I also have one which I already we use that form. We have one what? We have one bijective formula, bijective rule, which is what? Which is what? Number of favorable ways of occurrence of an event equal to be what? Total number of ways minus number of unfavorable ways of occurring event. This formula we use with what? Where we use this formula? That A intersection B complement 1 divided by 2 or not. In that formula we use this one. Okay. Okay, if you have any doubt in problem set, you can ask.
So can I ask?
Okay. Yeah, I have one question, which is also I think in the problem sheet also. Just okay. So question is, you have to make up. You ask to make a password. Mhm. So password of 6 letter. Okay. So 6 letter by using only alphabet. So how many ways you can make a password with replacement or without replacement? mm, with repetition and without repetition.
So alphabet is allowed, sir.
But only alphabet are allowed.
The lowercase, uppercase.
No, only lowercase.
26.
So
With
first,
that's going to be 26 to the power 6. Without repetition, it's going to be 26 factorial by 20 factorial. No?
Okay, with repetition, how many?
26 to the power 6.
26 power 6.
Yes.
Okay, and without repetition,
26 factorial by 20 factorial. Yeah,
6.
26 P6.
Yeah. So everyone, how to got this answer? I have to explain or you know?
Got it, sir.
Okay.
Got it.
Now, one another question I have. Assume that there are 5 boys and how many girls? 4 girls. Okay. Then how many ways you can arrange in the line such that no two boys are consecutive or no two girls are in consecutive. Okay.
5 factorial into 4 factorial.
No.
Sorry, 5 factorial plus 4 factorial.
Okay, that's I.
Sir, can you
5
please
factorial plus.
repeat the last line of
So
question?
no two girls are in consecutive way, means if one girl is here, then here one another girl is can't be here. It can be here, it can be here. No two girls are in next to each other. Okay, and no two boys are also next to each other. Okay. Assume that this is also 5. Yeah.
Then 5 factorial plus 5 factorial, sir.
Okay.
Like 2 into 5 factorial.
5 factorial into plus 5 factorial. Okay. One answer is this. Any other answer? Any other?
So, but the like boys and girls are independent, and we have to do that simultaneously. So, it should not be 5 factorial times 5 factorial, the multiplication.
I have to learn. Another answer is 5 factorial into 5 factorial. Okay. Let's
I
see.
think, sir, 2 into 5 factorial plus 5, like 4 into 5 factorial will be the answer.
4 into 5 factorial. Okay. Any other answer?
The 2880.
2880. Okay. Okay, let's discuss that. So, firstly, permute all the boys. Okay. B1, B2, B3, B4, B5. Now, condition is that they can't be next to each other. Means one girl here, one here, one is here, one is here. I can also permute one girl front of it also. So for boys, how many ways I permute this?
5
5 factorial.
factorial.
Okay. Now for girls, how many ways? So I have how many
2
position I
into 5
have?
factorial, sir.
1, 2, 3, 4, 5, 6 position are there. So I choose how many position I need. I need only 5. So choose
That is going to be 6 choose 5 at times 5 factorial.
what?
6 choose 5
Yeah.
times 5 factorial.
Yeah. And just
How,
Yeah.
sir? Could you please tell me? Explain.
So assume that firstly I assume permute B1, B2, B3, B4, and B5. Okay.
That part
Then
I understood, sir.
okay. Then I have how many positions I have left? 1, 2, 3, 4, 5, and 6. Okay. I can't permute two girls here. Otherwise, they are next to each other. Okay. So for separation, assume that like this. I have some grid like this. One, two, three, four, five, six, seven. Okay. Now I choose B1, B2, B3, B4, B5. Okay. Now how many girls I have? 5. So 1, 2, 3, 4, 5. But one another case is what? Girls can be front of the row.
Yes,
Okay.
sir.
So I have 6 positions. I choose 5. So I can choose all this, 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 this. Okay. Or I can choose this, this, this. Just a second. I made a mistake on. If I choose this and this, then I have how many? Okay. And then this 1, 2, 3, 4, 5. Okay. Okay. Sorry. I made some mistake.
Sir, 4 will be between the 5 boys, and one the last can be either at this side or that at that side.
Yeah.
Yeah, that's going to be 2 times
Yeah.
7.
That's why. So okay. So how many position I have? 1, 2, 3, 4, 5, 6. If I choose from 6 to 5, this means 1, 2, 3, 4, 5. Then these two boys are next to each other. So I have to be
Yes, sir.
remove this one, and then I have how many? How many position I have? 5.
Yes, sir.
So 5 factorial. Okay, here I have answer is what? Into 2. But if
Yes, sir. 5.
what if I have 4 girls only?
Then it will be 5 factorial into 4 factorial,
Why
right?
is it into 2, sir?
No, 2 because of girls. See, in this case, I choose firstly B1, then B2, and then I permute to fit girl here. Okay. What if the girl in the front row? Okay. For that I multiply 2. Okay. Just if we have 5 boys and 4 girls, what's the answer?
Then 5 factorial into 4 factorial, sir.
Okay. Let's see. I have G1, G2, G3, G4. Okay. Now,
Yes, sir.
how many position I have? 1, 2, 3,
5
4,
positions
5. So for this we have 4 factorial,
into 5 factorial.
and for boys we have how many? 5 factorial.
Yes, sir.
Yeah.
If there are 3 girls and 5 boys, sir.
Okay. Let's see what's the
Then it is not
then
possible. Like,
not possible. See,
No, the condition
if
says 2 girls should not be next to each other, but 2 boys can be next to each other then.
okay, then the question is totally changed.
yes, sir.
Yeah. Then at that case, assume that B1. How many boys we have? 5 and 3. Okay. So firstly permute what? G1,
Girls,
G2, G3. Okay. Then how many position we
B
need?
factorial, sir.
So assume that these are 3 factorial, then one boy can be here, 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 also here, okay, also here.
Sir, position of two boys is fixed, but the left three boys can be anywhere.
What?
Uh, like there can be two boys in between two girls also. Like if you're
Yeah,
saying
yeah,
that
yeah.
two girls,
That case is also there. Yeah, yeah. So it's a totally different case. We have to be see all the cases.
it is complicated a little bit.
Let's see whether B1, B2, B3, B4, B5. Okay. Now one gap is here, one gap is here, one gap is here, one gap is here. Maybe one gap. Now so and one gap is here. Okay. Now I can put one girl is here, also here, also here, also here, also here, also here. So for these I have 5 factorial. Then for how many position I have? 1, 2, 3, 4,
Six.
5,
Six
6
positions.
into 6 into then into 5 into 4. This is the answer. Okay. I have to explain or you?
How, sir?
Yes, yes,
This
sir.
interesting.
So 6 into 5 into 4 divided by, so it is like choosing 3 gaps from 6 gaps will come, right, sir?
I
Yeah,
think, sir, 6C3 will be there, like 5
Ah,
factorial into 6C3.
so 5
what?
factorial multiplied
6
by,
that is also 6C3 is the 6P3.
no,
Permutation is
6C3,
there.
sir.
Yes,
Oh,
sir.
See.
6
permutation will come.
6P3. Yes,
Yeah,
sir.
Oh,
yeah.
5
That's
factorial into
see
6P3.
B1, B2, B3, B4, B5. How many ways I can arrange this? 5 factorial ways.
yes, sir.
Okay.
Yes, sir.
Now I have how many gaps I have?
6 positions.
6 position I have. And how many girls are there?
3 girls.
So choose 3 position. So which is what?
Uh,
6C3.
6.
Then
Yes,
permute
sir.
those girls. How many? Which is what?
Oh,
This is the
Yes,
formula
sir.
of permutation.
okay, okay.
6P3. Yeah.
Okay, got it, sir.
Okay. Okay. Can we end the class? I have to do.
When is the next session, sir?
Tomorrow we have next session.
Oh, tomorrow.
And that is the solve with us, I think.
Okay, sir. Fine.
Yeah.
Okay, sir.
Sir,
Thank
we have
you,
a general doubt.
Okay. Ask.
Sir, I get in 2 lectures, but I have gone in YouTube playlist. In statics, permutation lecture is 6.
Okay. Permutation lecture is 6.
So, actually, on the YouTube video playlist, it has compiled week 5 and week 6 videos. That's why
Yeah, like some of the like titles are interchanged, I think.
So you can access your that
Sir,
course page.
I have get only 2 video lectures.
Yeah, only 2 video lectures are there. All other are the tutorial sessions.
But sir, in YouTube playlist is 6 video lectures.
For permutation week 5.
Yes, sir.
they are
Okay.
showing also that on YouTube, or the what our dashboard shows as a week 6 content is also shown. They are labeled as that. That's only. If you
Okay.
compare,
Maybe they change their web page, I think, this time.
Okay.
so it's better that we follow what it's in our dashboard.
Yeah, you have to follow your dashboard
Okay.
because I think they follow your dashboard weeks, no?
Yes.
Sir,
Yes, sir.
Yes, sir.
so could you drop a few hints like even like sometimes it's hard to differentiate that these events are dependent, independent, or like how we should break the sub cases.
Okay.
So that becomes sometimes tricky. Would you like to suggest some points to note for that?
Main points are if you divide your problem into case, then at the end of solution you have to be add those case, not multiply. Okay. Main point is this.
Okay, sir.
Yeah, as in that example, I divide my problem into head and tail, and after that I add those things. Okay, so I
So
can't
these are
multiply
for dependent guesses.
in any problem. If you divide your problem into cases, in any problem, this is not in particular. If you in general, if you divide your problem into ways, then you have to be use addition in the last to find the total answer. Okay, main point is this. After that, you have to be see if my cases are dependent or not, so that I can use multiplication or not. Or you can follow it. I think in 11th you have permutation chapter or no? In 12th, I think in 11th.
11th.
Yeah, so you can see in books and try to solve some question. They will give you when to use addition, when to use multiplication, when to divide your problem into sub problems, and basically in cases. Okay.
Yeah. Okay, sir.
I have a doubt now.
Okay, what's the doubt?
Sir, that activity question is not to practice questions.
What?
So where the activity question is not sufficient to practice and solve. So where
Okay.
I go to more questions.
In book, or I think tomorrow we have solve it session. There will be the some problem, nice problem, I think. Or you can also follow any book, or I think in any probability book there will be there is a chapter counting principle and this.
The, the activity question and grading questions are so different to in book.
What? Not in not in your academic book. You can also follow other books. Usually this counting principle are not used in that much in probability theory and stats. That's why there is only 2 lecture and few activity are there. They are only used I think for first last means upcoming 2 and 3 weeks. After that you never use this counting principle and this. But yeah, you have to know what is the counting principle or how to count this.
Sir, from week 6 onwards, what syllabus will be there?
It's totally probability theory, not probability theory. Yeah,
Probability.
probabilities. Till now you
Till which
discuss some data and static, means there is no uncertainty in uncertainty concept is not till now, but after this week you have some probability concept and that thing in means totally inferential, you can say inferential statics, not descriptive.
Okay, this is part of inferential statistics.
Yeah, this one is also part of, not actually part of inferential statics. This is only a totally different, this is not even part of statics.
Like, then when will inferential statistics start? From which week?
Next week, 6th week.
From sixth week.
Yeah, from probability, when you deal with the probability and random variable.
Random variables is in last week, I think, binomials and all.
Those are the types of random variable. Some particular special random variable. Those are not only random variable. There are thousands of random variables. there are specific names of random variable with some property.
Okay.
Yeah. Okay.
Okay, sir. Done.
Okay. Thanks.
Thank you for the session, sir.